Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous video, we have solved a question in which we were trying to find the minimal automata for a given question. On the similar basis, we will solve one more question applying the same algorithm. In the diagram, you can see that an automata is given which contains 6 states: Q0, Q1, Q2, Q3, Q4 and Q5. We will have to reduce this automata to the minimal number of states. As we all know, the first step for reducing the number of states is finding all states which are inaccessible from the initial state. Let's try to find whether all the states given in the automata are accessible or not. Q0 is the initial state, hence it is accessible. On the symbol 0, there is a transition from Q0 to Q1, hence Q1 is also accessible. On an input 1, there is a transition from initial state Q0 to the state Q2, hence Q2 is also accessible. We can see here, on string 0 followed by 1, there is a transition from the initial state Q0 to the state Q3, hence Q3 is also accessible. On an input 1, 1, there is a transition from the initial state Q0 to the state Q4, hence Q4 is also accessible. We can see here that there are no combinations of input possible which will have a transition from the initial state Q0 and reach at state Q5. Hence we can say that Q5 is a state which is inaccessible. Hence we can remove the state without any hurdle. So on step 1, the accessible states are Q0, over here we can see that Q0, Q1, Q2, Q3 and Q4 are accessible state, whereas Q5 is an inaccessible state. So hence our minimal automata will not have a class for Q5. In the second step, we will apply the algorithm to find out which of the following state belong to the same class. So let's start with the first step, that is classifying the given set into two classes, final and non-final. Over here we can see that state Q0, Q1 and Q2 are non-final, Q3 and Q4 are final, Q5 is already removed. We have made two classes, Q0, Q1, Q2 in one class, Q3 and Q4 in another class. Now let us try to apply inputs these state and find out whether they have a transition to the same class or different class to find out whether the states belonging to the same class are indistinguishable or not. Over here, let us check first the pair Q0 and Q1. Q0 and Q1 on transition 0, Q0 and Q1 on input symbol 0 have transition to state Q1 and Q2 respectively. Q1 and Q2 belong to the same class. Q0 and Q1 on input symbol 1 have a transition to Q2 and Q3. Q0 and Q1 on input symbol 1 have transition to states Q2 and Q3 respectively. Out of them, Q2 is in class 1 and Q3 in a different class, and hence Q0 and Q1 must be distinguishable classes. Let us try to compare Q1 and Q2. Q1 and Q2 on input 0 have transition to the same state Q2. Similarly, Q1 and Q2 on input 1 have transition to states Q3 and Q4, both of them belong to the same class. Using various input alphabets, we can verify that Q1 and Q2 have similar transition, and hence Q1 and Q2 must belong to the same class. We have formed three classes over here. Q0 is one class, Q1 and Q2 is another class, Q3 and Q4 is one more class. Now, we have already done with the class Q0, Q1, Q2. We have split that class into two equivalent classes again. Now we will try to do the same thing with this class containing Q3 and Q4. As you can see here, Q3 and Q4, both states have transition to Q3 or Q4 itself on both input 0 and 1, and both of them belong to the same class. Hence we can say that Q3 and Q4 have similar transition, they belong to the same class. So the final classes after applying the second step of the algorithm left are Q0 as one single class, Q1 and Q2 belong to the same class, Q3 and Q4 belong to the same class. Now let us try to draw the minimal DFA from the given classes. From the original DFA, we know that Q0 on 0 have a transition to Q1. In the original DFA, we know that there is a transition from Q0 to Q1 on input 0. Here, we will mark that from the Q0 class to Q1, Q2 class. On input alphabet 1, there is a transition from Q0 to Q2. That also is marked from Q0 to Q1, Q2 class. From both state Q1 and Q2, on the input 0, there is a transition to Q2. That will be marked at class Q1, Q2. From both Q1 and Q2, on the input alphabet 1, there is a transition to class Q3 and Q4. As we have already combined Q3 and Q4 into a single class, this will be a single transition. From Q3 and Q4, on both inputs 0 and 1, there is a transition to Q3 or Q4 itself. We have designed the minimal DFA for the given question. The minimum number of states required over here are 3. With this, we have solved one more question of finding the minimum number of states required in a DFA for a given question. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe to the channel.